All right, so these are the questions that go with the lab, and I'm going to get you started on these. We'll talk about big picture concepts with them, and I've already done a little bit of that right here when we talked about what the lab really means to us. So these are my set of questions trying to lead you into understanding this. So we'll try it again from a little different perspective. So which pairs reacted with each other? We did that. There are 3 pairs, and there were the 3 in these boxes here. This one, this one, this one. So it was chlorine and sodium bromide, chlorine and sodium iodide, and bromine and sodium iodide. Or you can look over here on the board. These are the 3 pairs that reacted with each other. So you write those down. I'll just go ahead and show you what I want. I'll do one, you do the others. So one of the pairs that reacted with each other. Remember on your Chromebooks you can do a command comma to get a subscript. So Na Br and Cl2. So if you highlight the number and do a command comma, control comma on a Chromebook, you get that subscript. If you have a MacBook, it's command. All right, so that's what I want you there. Now, that's one of 3 pairs. Okay, there are 6 pairs that did not react. I just want you to get practice writing stuff. So one of the pairs that did not react was, it was Cl2 and NaF. So that one was no reaction. That was the first box. Again, go to the subscript. Okay, so that was a no reaction mixture. That was this one up here, right there. Yes? I only wrote one. You have to figure out the other 2.
Oh.
So I'm getting you started.
Wait, can you go down?
Yeah. So that the pair that this is one of the pairs that did not react. Chlorine and NaF. See what I mean by pairs? So come down here. There are 6 pairs. This is one of the 6. All right. Now the 3 pairs that reacted, we're going to write those again. So the easy way to do that, you've already written them up here. Copy it and just paste it right here. So there, now we're going to talk for each pair, change the font color to red for the element that was replaced and green for the element that replaced it. So in this, between these 2 chemicals, what got replaced? NaBr or Cl?
NaBr. Br.
Both the Na and the Br or just the Br?
Just the Br.
Just the Br. So that's this equation. So the Br was pushed out. Does that make sense?
Mm-hmm.
Okay. So we're going to make the one that got replaced red. So to do that, you highlight it. And then up here at the top, there's a thing that says red.
Oh.
And then you come back down and make, so now it should be red. See it? Red. All right, and the chlorine needs to be green because that's what replaced it. The
Right.
chlorine pushed the bromine out. So we're going to make that green. So come up here and make it green. All right, that makes sense? So that's one of 3 you're going to do that to. There are 3 pairs. This was one of them. You guys will finish on your own. Now, were the green atoms bigger or smaller? So look at chlorine. Look at the green chlorine compared to the red bromine. Is chlorine bigger or smaller than bromine? The chlorine is smaller. That's right. So right here, this is chlorine, and it's smaller than bromine. So the green ones were smaller. So I'll let you write the word in, but that was your answer. Now look at number 5. Number 5 is starting to get you into the concept of oxidation and reduction, which we haven't talked about at all yet, but we will. So when the atoms in green were alone, their charge was 0. But when they made the replacement, their charge became negative. So if you look up here, is this charge 0 or negative?
I can't see that.
0 because by itself. But over here, it's negative. So in order to become negative, does it lose electrons or does it gain electrons?
Gain.
It gains them. Very good. So chlorine gained electrons. So now, can we reach the next level of understanding? Do small atoms or big atoms gain electrons more easily?
Small atoms.
Small ones do. That's right. So small atoms gain easier, which makes them more chemically active if they react by gaining electrons. All right. So chlorine, the small atoms gain more easily. So then what would be the most active halogen? Here are the halogens. Fluorine, chlorine, bromine, iodine. Which one's going to be the most chemically active?
The smallest one.
The smallest one, which is? Fluorine is your answer. Or we didn't actually have any just plain fluorine, so I also would take chlorine on that because of the three that we had. Chlorine, bromine, iodine. Chlorine was the one that did the most damage. It replaced the most stuff, right? But you could say, if you're wondering then how can we say it was fluorine based on our lab, if you go back to up here at the data table, was there anything that replaced the fluorine? Nothing replaced it, right? So therefore fluorine must be really the most active because nothing was strong enough to push it out. Nothing was strong enough to replace the fluorine. Okay, that's the end of the lab. Hope that helped, and you can fill out the data table and answer the questions and turn it in. Don't forget up here, there's 3 pairs, not just one. There's 6 pairs, not just one. There's 3 pairs, not just one. And we answered these out loud in the video or in class. That's the end. We can cut the video.